So in this question, you are given an integer array ARR, and we need to sort the integers in the array in ascending order by the number of ones in their binary representation. And in case of two or more integers have the same number of ones, you have to sort them in ascending order. Then we return the array after sorting it. So in this input array, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, a normal ascending array. And the output, as you can see, has changed its order. Now the explanation that they're given is that when you have 0, it is the only integer with 0 bits, and 1, 2, 4, 8 all have 1 bit, meaning there is 1 in the binary representation. This means there are 2 ones in these numbers binary representation, and these have 3 ones in 7 in the binary representation. So basically, since we're basing these things off of the binary representation, I would first traverse through the loop and basically create the binary number for each of these numbers in the array. And when you print that, you can see that you get the binary representation in the form of a string. Now, because it is in the form of a string, we can basically traverse the characters in the string and count the number of ones in that string. So we can say for character in binary number, if ch equals 1, then we can increment this by 1. Yep. And so since we technically want there to be buckets where each bucket's key is basically how many ones are in the binary representation, and the value is an array of all the values in the original array that have that as the binary representation. So the idea is to first create a bucket, which is going to be in the form of a key value pair dictionary. And what we'll do is if count ones is in the bucket already, then what we can do is for the bucket at count ones, we can append the current number that we're at. Otherwise, we can just initialize it with the existing number in the form of an array. Now, we can basically see what the bucket will have for how we sorted it using bucket sort. And as you can see, it has the 0 value in 0, as 1, 2, 4, 8 for the 1 bit, 3, 5, 6 for the 2 bit, and 7 for the 3 bits, just like this explanation here. So we are on the right track. One thing we have to notice is that if we have an extra test case like this, you can see that the keys are not sorted. So what we need to do in this case is to sort the keys. So to sort the keys, we create a new dictionary, and we basically create a sorted Python type of the bucket items, and then we create a dictionary out of that, since sorted makes it different. And then when we have the sorted dictionary, as you can see, these are now properly sorted for the keys, which is what we wanted. And then, so obviously this cannot be our output since we're expecting a list of integers. We can traverse through the dictionary to create an output array called res to signify the result. And then since the value is in the form of an array, say for num in val result.append the number, and then here you can see that we get the final output exactly how we want it. Oh, and one thing we missed is that the actual array needs to be sorted as well in ascending order, so let's fix that. Yeah, now everything is working out like it should. Yeah. And so just to recap, what we did was we traversed through the numbers in the array, we created the binary representation, we counted up the ones in the binary string, we created a bucket for each of the ones to basically add those values that have that amount of ones in the binary representation. Then we sorted the keys in the bucket to ensure that everything is in ascending order by the number of ones as well as the values within the bucket, which we did here, and then we appended it to a resulting array and we returned that here. So yeah.